being a part of a democratic society like ours makes us internalize this idea of one person, one vote. The votes are all weighted equally. Everybody has an equal say. Now, a lot of times that's a great mantra, but there are times when it's actually helpful to be able to weight votes and have one entity be more important than another in the voting system. Things like this happen at like an international level with the UN, where there's countries that have a little bit more pull than other countries. Things like this happen in executive boardrooms at companies, where one person's say is a little bit more important. So when they vote on something, that person gets a little more pull, and so on. So if we're going to talk about these voting systems where it's not necessarily a one person, one vote, they're all weighted equally, then we're going to be talking about a thing called a weighted voting system. Now, weighted voting systems have 3 elements. That number 3 hopefully is familiar from our voting systems in the first place. Now, the first thing, the entities casting ballots, we're going to call them players, because a lot of times in a weighted voting system, they're not actually people, they're not voters. Individually, they are, in fact, some kind of entity. So we'll call them players. Now, every player is going to be assigned a weight. The weight is the number of votes that each player controls. Now, to make things match up, we're going to number the players and their respective weights from 1 to n, where n is the number of players involved. And so player 1 will have weight 1 assigned to them, player 2, weight 2, and so on up to player n and weight n. Another thing that we need to know in a weighted voting system is a quota. The quota tells us how many votes are required for something to pass. Now that something, as we're talking about weighted voting systems, we're going to focus on motions. So a motion is a statement or question that has 2 options. You can say yes to it or you can say no to it. That's the only way that the players can vote, yes or no. There are no other options. Now, the quota is basically saying how many votes are required to pass the motion in a yes or no direction. So when we're talking about weighted voting systems, we're going to use this notation. Q is the quota, W1 is the weight of the first player, W2 is the weight of the second player, and so on up to Wn being the weight of the nth player. And we'll rank the weights so that the player with the largest weight, who controls the most votes, will be player 1, with weight 1 being greater than or equal to weight 2 for player 2, and it would be greater than or equal to all the way up to greater than or equal to weight n for player n, being the least powerful of the players. Now, several things can go wrong in a weighted voting system. The first one is that we can have some mathematical version of anarchy occur if the quota is less than a simple majority. If the quota is less than a simple majority, then that means that we could get enough yes votes and enough no votes for the motion to pass both with a yes and a no vote. And so there's chaos. And that's our mathematical version of anarchy. So in general, we want to make sure that our quotas are greater than a simple majority, or at least a simple majority, so that both yes and no cannot win. We also can get a mathematical version of gridlock, where we can't actually move forward if our quota is larger than the number of votes available. So if I add up all of the weights, I know how many votes are available. And if I require more votes than that for a motion to pass with a yes or no vote, then I'll never get the votes required, and I'll cease all motions of whatever committee is working to vote, our math version of gridlock. So we want to avoid having our quota being greater than the sum of all of our weights. We also can end up in a situation where the player with the least number of votes, or someone with a very small number of votes, even if it's not the least, is a person who has a ton of power. And that happens when we actually need that person in order for the motion to pass. So say I have my person with the least number of votes, and their weight is 3. And my quota is actually only 2 less than the sum of all of the weights. Well, then that player that has 3 votes and the smallest number of votes, I need them to pass my motion. So it can happen that in a weighted voting system, even the player with the fewest votes can have a ton of power depending on where the quota line is set. Similarly, on the other end of the spectrum, we can have a dictator situation arise if one of our players has more votes, so their weight is greater than or equal to the quota. So say player 1 has as many votes as are necessary for the quota. If that player has that many votes, regardless of how anybody else votes, that player's direction, yes or no, is going to carry with the motion. So player 1 is in essence a dictator. Also, if we have our quota be such that it's greater than how many votes player 1 has, but player 1 can control whether the motion passes or not. So we need player 1, the person with the most votes, to vote yes or no the direction we want them to for the motion to carry. Then player 1 has what's called veto power. Player 1 is a spoiler. If player 1 decides to vote against everyone else, and we have to have player 1 to get our quota, so the sum of everybody else's votes is not enough to make the quota without player 1, player 1 can, in essence, decide that they want to veto the passing of everyone else's. And we call that veto power for them. So there are lots of issues that can arise in weighted voting systems, and we just need to be careful about what weights everyone has and what quotas we're choosing for motions to pass with yes or no votes.